All right. Welcome, Math 2 people. We've got our first lesson of the year, and this is just a review of some stuff about angles. What I want you to do with your notes is put your name up here in the top corner and also the period that you are in. Our question, this is going to be something that you answer at the end as a summary. So our question today, which after the notes you should be able to answer, is why can't all angles be named using only one letter? So why can't you just call them angle E or angle B or angle F? There's certain situations where that does not work. So we would need to keep that in mind because that can be a little bit tricky when we're naming our angles. All right, so let's just talk about how to name an angle. So naming angles is our first subject that we're going to cover. Now, when we name angles, there are three ways that we can name an angle. We can use the angle sign and three letters. That's probably the safest way to name an angle, is use the angle sign and then three letters for the angle. We can do an angle sign, and sometimes we can use one letter. But as we've seen in our question up there, it's not always going to work. But this is sometimes a faster way to name the angle, and it works sometimes. Last way we can name an angle is the angle sign and a number. But of course, this one also does not always work because they don't always have numbers inside the angle. All right, so let's start with an angle and see what it looks like. So we've got an angle here. All right, so I'm going to call this angle, let's put a point here and call that point A. The vertex here will be B. And then over here we've got C. And then I'm going to put a number 1 inside. Notice it doesn't say 1 and then the degree mark. It's just a number 1. So that's actually one of the names of the angle. So in this particular instance, we can name it with 3 letters. Now when we name it with 3 letters, we can name it as angle ABC, or we can name that angle as angle CBA. Now notice that either way that I did it, B was the middle letter. The middle letter has to be the vertex. Okay, so this is our vertex. So we can go ABC or we can do CBA. So those both have to be the vertex. So on this ray on the side, you could use either A first or C first, it doesn't matter, but B has to be the middle letter. Okay, if we wanted to name that with one letter, we could call this angle B. So in this instance, angle B would work. If it has a number like that without the degree mark, we could also call that angle 1. So all 4 of those names would be appropriate for that one. So we could have named it with 3 letters, 1 letter, or even a number. Now let's do a different angle this time. And show you why you can't always use 1 letter, and sometimes you have to use 3 letters. All right, so we have several angles sitting here. I'm going to name this D, this will be E, this will be F, and this one will be G. Let's put a 2 right on this one. So we're talking about just that angle right here. Now in this instance, if I wanted to name angle 2 other than angle 2, I cannot call it angle E. Why? Because if I said angle E and didn't give any other context by saying it's this angle, you might think I'm talking about this angle up here, angle DEF. Or you might even think it's DEG. And then some people would think, oh, he's talking about FEG. So since there's 3 different angles sitting at angle E, just naming it one letter is confusing. Nobody would know what you're talking about. So in instances when there's more than one angle at a vertex, so angle E has 3 angles at that vertex, you're not allowed to use one letter. In this instance, you would either use 3 letters, like angle FEG, or angle GEF. Notice that the E is the vertex and it's in the middle for both of those. So the only time you can call it with one letter is when there's only one angle there and nobody else can be confused about which angle you're talking about. All right, next thing we need to cover is adjacent angles. So an adjacent angles are a pair of angles. So there's 2 of them. And the rules for adjacent angles is they have to have the same vertex, so they share a vertex. And they share a side. Now remember, the sides of an angle are rays, so they share a ray. All right, what does that look like? Let's put a whole bunch of angles up here. So I'm going to start with the straight line on the bottom. And let's just make a whole bunch of rays coming out of here. So put one there, put one here, and how about another one over there? That sounds good. All right, so I got a bunch of angles sitting there. Let's go ahead and call this H out here. The vertex right here will be I. Call this one J. This one will be K. This will be L. And this will be M. All right, so let's find some adjacent angles. Okay, let me put some numbers on some of them just so it's not as confusing. So I'll name this one 3, angle 4, angle 5, and angle 6. All right, so let's look for angles that are adjacent to each other. All right, so angle 3 and angle 4 would be adjacent to each other. So let's say angle 3 and angle 4. Now, why are they adjacent? Well, both of these angles has I as a vertex. So they have the same vertex of I. And then these 2 angles share this ray right here, ray IJ. Angle 3 has that ray in it, and angle 4 has that ray in it. So they have the same vertex, and they're sharing this middle ray. So basically, they're right next to each other. That's what adjacent means, is next to. So the shared side in this instance would be ray IJ. All right, let's look at a couple other ones. Let's do angle KIM. All right, so let's look at it. K is here, I, and then M. So that's angle 5 and 6 together, so KIM. Now, what angle would be adjacent to that one? Well, you can't say 5 because 5 is inside of it. They have to be next to each other. So angle 4 would work. Now, KIM and angle 4 are adjacent because I is the shared vertex, and then KIM and angle 4 have this ray in common, IK. So there's our shared side. All right, last question. How many angles are adjacent to angle 5? Okay, so here's angle 5. That's KIL. How many different angles are adjacent to that angle? Well, you might be saying there's 2. You might say angle 4 and angle 6 are adjacent to angle 5. And that's partially correct. There's another angle, though, that you missed. So angle 4 is adjacent because it has a vertex of I and it shares IK. Angle 6 is adjacent because it's a vertex of I and a side of array IL. But we can also think of KIH as being adjacent. So it has angle I, and then it has the KI as adjacent. So what's adjacent to 5? 6 is, 4 is, and KIH is. So there's actually 3. Angle 4, angle 6, and angle KIH. Next. All right, next we got complementary angles. Hopefully you remember these. Complementary means that the sum of the two angles adds up to 90 degrees. So it's two angles whose sum equals 90 degrees. Now these two angles do not have to be adjacent. So you could have something in like this. Here's one angle, here's another angle. Those two, since you add them together, they would make this 90-degree angle. Those would be complementary. So you could have adjacent complementary angles, but you could also have non-adjacent. Let's say I had an angle over here that was 40 degrees, and then I had another angle over here that was 50 degrees. Even though these angles are not adjacent, they are still complementary. It just has to be any two angles that add up to 90 degrees. So those are complementary. Supplementary is next. And if you remember from last year, that means the two angles add up to 180. So two angles whose sum equals 180. Again, they can be adjacent or they can be non-adjacent. So they can be next to each other or they don't have to be next to each other. So you could have one over here that was 80 degrees. And then you can have another one over here that's 100 degrees. And these two angles, since they add up to 180, would still be supplementary. They could also be next to each other. Now, when they are next to each other, we call them linear pairs. Linear pairs are adjacent and supplementary. So in this case, the two lines, since they add up to 180, would always make a straight line together. So let's call this angle 3 and angle 4. See how angle 3 and angle 4 make this straight line together? They're adjacent because they share this ray right there. So they would also be supplementary. So we can say that the measurement of angle 3 plus the measurement of angle 4 would be 180 degrees because a straight line has 180 degrees. And that's where supplementary comes from. Last thing for today is vertical angles. All right, so vertical angles. They're formed by two opposite rays. And when you have two opposite rays, basically you have two lines that intersect. So two intersecting lines. So what's that look like? It looks like this. There you have two intersecting lines, and it always forms four angles. Here's one angle, here's another one, here's the third one, here's the fourth one. Now what we learned last year is that 1 and 3, so the angles across from each other, those are the vertical angles. And we also learned that vertical angles are congruent. So we can say at this point that angle 1 is congruent to angle 3. And angle 2 and 4 would be vertical angles as well. So we would say that angle 2 is congruent to angle 4. Now what's that congruent sign mean? Well, if you remember from last year, the congruent sign means that the measurements are equal to each other. They're not in the same spot, but the measurements are equal. So we could also say that the measurement of angle 1 is equal to the measurement of angle 3. So they have the same degrees. So if this were 70 degrees, angle 3 would also be 70 degrees. If this were 110 degrees, angle 4 would also be 110 degrees. So the measurement of angle 2 would be equal to the measurement of angle 4. All right, that's all I got for you. You should, at this point, be able to answer the question at the beginning. Why can't all angles be named using only one letter? Okay, so we talked about it here in this section. So in your summary, you need to answer this question. So at the end of your notes, start a new section that says summary and answer that question. That's all we got for today. Bye-bye.